This video provides a short introduction to the beer game. You should watch this video after you have read the web-based beer game exercise note. The beer game is a simple supply chain management simulation for beer distribution. In this supply chain, we have one beer manufacturing company, one distributor, one wholesaler, and one retailer. The simulation controls the end consumer orders. You have been assigned to one of 4 roles. Most of you will be assigned to a 2-person team. You will need to decide each week how much to order from your upstream supplier. Everything else, such as shipments and receipts, is calculated by the simulation automatically. The simulation will have you make this decision for many weeks. Your objective is to minimize total cost of your entire supply chain. In each week, you can incur a backlog cost or an inventory holding cost. A backlog cost refers to your cost of not fulfilling the demand that week and is $1 for each keg of beer that is backlogged at the end of each week. Your backlog cost is persistent because orders cannot be cancelled. Thus, if you cannot fill an order in a given week, it will be backlogged each week until you fulfill it. If you have more beer in inventory than is being demanded, you will incur an inventory holding cost of 50 cents for each keg of beer that remains in your inventory at the end of each week. As you enter the game, the weekly demand over the past many weeks has been steady at 6 kegs per week. Starting inventory of each role in the supply chain is 18 kegs. The game begins in the last week of May in the Northern Hemisphere, so demand is likely to increase with warmer weather. A new marketing campaign is planned toward the end of summer to keep demand from falling. The identities of the other players in your chain are not revealed to you. You are not allowed to communicate with the other teams in your supply chain except by placing orders. To increase the learning from the simulation, we have 3 versions. You and your entire supply chain will be playing just one of the 3 versions, and everyone in your chain will be in the same version. Version 1 is a base case with 2-week lead times and does not provide full point-of-sale visibility. Versions 2 and 3 each change one of the base case assumptions. Version 2 has shortened lead times and version 3 has full POS visibility. The next 3 slides provide more detail about each of these 3 versions. In version 1, the base case, all members of your supply chain will experience 2-week lead times for order processing and 2-week lead times for transportation except for the factory and the retailer. A fixed order processing lead time occurs when a firm issues an order to its upstream supplier. In version 1, this lead time is 2 weeks. And so, for example, an order issued by a distributor in a given week will have the order arrive 2 weeks later at the factory. Each shipment from one role to the next downstream role incurs a fixed transportation lead time. In version 1, this lead time is 2 weeks, and so, for example, beer shipped from the factory in a given week will arrive 2 weeks later at the distributor. Instead of ordering from a supplier each week, the factory issues a production request for a specified number of kegs to be produced and delivered to the factory warehouse. Thus, rather than facing a 2-week order processing lead time, the factory faces a 2-week production lead time. In this 2-week version of the simulation, kegs of beer are delivered to the factory and thus available to sell 2 weeks after the factory issues a production request. It then takes 2 weeks for delivery from the factory to reach the distributor. Between the end consumer and the retailer, there is no lead time in order processing or transportation. That is, when end consumers order from the retailer, the order is processed by the retailer immediately, and product is delivered immediately if the retailer has sufficient inventory. In this version, end consumer order data are visible only to retailer and not the other supply chain roles. We refer to this version with no full POS visibility. In version 2, all lead times become 1 week. As in the base version, end consumer order information is visible only to the retailer. So again, we have no full POS visibility. In version 3, lead times are back to 2 weeks, but all players in your supply chain have POS visibility and are thus able to see consumer order information in real time. The simulation's landing page will show which version of the simulation your supply chain is using and what your specific role is. In this example, the landing page shows that you will serve as the distributor in a supply chain with 2-week lead times, and that the factory, your distributor role, and the wholesaler in your chain do not have POS visibility. You can also see the lead times noted along the arrows in the diagram. After you start playing, you will see a simulation interface like this. It shows your role in a big box. In this case, you are the distributor. Clicking the Info button at the top right of the screen will show you a screen that reminds you about lead times, inventory costs, and backlog costs. You can also see the lead times along the arrows between the roles. Your point of sale or POS visibility is set to off, and this is also reflected by the fact that the rightmost column titled Consumer Order is grayed out and says NA for Not Available. If you have POS visibility, you will be able to see the end consumer demand in this rightmost column. In this example, the interface shows that you are now in week 3. The table also shows the historical information. Each week, the only decision you make is how many kegs of beer to order. You need to type a whole number between 0 and 99 and click the blue Send button. Let's walk through the sample data in the table. Assume you, as distributor, ordered 6 kegs in week 1 and 6 kegs in week 2. Then, in week 3, your beginning inventory in week 3 is the same as week 2 ending inventory, which is 18 kegs. You receive 6 kegs from your supplier, so current inventory is 18 plus 6 equals 24. You receive a customer order for 5 kegs from the wholesaler, who is your customer. You ship 5 kegs to the wholesaler. As a result, your ending inventory is 24 minus 5, or 19 kegs. You can never have positive backlog and positive ending inventory. Cost for week 3 is 50 cents per keg multiplied by end inventory plus $1 per keg multiplied by backlog. So what the actual numbers is 50 cents per keg multiplied by 19 kegs in ending inventory plus $1 per keg multiplied by a 0 keg backlog. This gives us $9.50. Your cumulative cost is $9.50 from week 3 plus the previous $18 for a running total of $27.50. Again, your only decision each week is how many kegs to order from your supplier. All resulting calculations are done automatically by the simulation. Now let's take a look at how lead times affect ordering and shipping. We first look at the base case with 2-week lead times. Suppose you, as a distributor, place an order for 5 kegs in week 1. Your supplier, that is, the factory, will receive your order for 5 kegs in week 3. If that factory has enough supply, you will receive shipment in week 5. If that factory does not have enough supply, it will send as much as it can. So you will receive a partial shipment in week 5. The remaining shipment will be delivered as soon as the factory has more inventory, and the factory may ship the remaining units to clear a backlog. If more orders have been placed by this time, shipments will fulfill as much of those subsequent orders as are available in stock. In supply chains that have 1-week lead times, the dynamics play out similarly, just with shorter lead times. As a result, your order placed in week 1 will be received by your supplier in week 2. And if it has enough supply, you'll receive their shipment to you in week 3. If your supplier does not have enough supply, you'll receive a partial shipment in week 3, and the rest together with subsequent order units in future weeks. Throughout the game, you can export a CSV of your data for analysis by clicking the Export CSV option on the top right of the screen. This is what your CSV file will look like. You should use just one computer for all order entry. If you want to analyze your historical data, please do so using a different computer. Both can be logged in, but it is important that you use only one computer to place orders. Your team should try to make each weekly ordering decision within 60 seconds. If you're taking too much time to make a decision, you will slow down your whole chain. Without your order, your supply chain cannot advance to the next week. If you are taking too much time, you will see a pop-up window like this. In that case, please submit your order right away. At the end of the exercise, those who do not have POS visibility, that is, the factory, distributor, and wholesaler in versions without full POS visibility, will be asked to draw a graph of what you perceived end consumer demand to be each week. We are asking for a rough graph drawn with your mouse. It does not need to be very precise. After submitting your graph, you will see the thank you screen. Those in the full POS visibility version or in the retailer role in any version will not be asked to draw demand and will see the thank you screen immediately. A few in-game instructions. If you mistakenly close your browser, return to the assignment in Canvas to log into the simulation URL. Your data will not be lost. You should select one person per team to be responsible for typing in the order decision and clicking Send. You should only enter whole numbers between 0 and 99 in the order entry field. The simulation will not accept text, symbols, or decimal entries. Make your ordering decisions as quickly as possible. Aim for within 60 seconds, but be serious about those decisions. If you need technical support, you can use the Live Support button on the top right of the simulation screen. This is what the Live Support window looks like. Just type in your question, and the tech support team will get back to you. This concludes the introduction to the beer game simulation. Good luck!